Hello everyone, welcome to the online course on manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So we are discussing about the casting and almost we have reached to the end of this casting. Next we will take welding, but before that, in today's lecture, we'll sum up all the things. To sum up all the things, we will take few numerical. So, as you all know, numerical that we are taking in this lecture series, we are taking from the previous gate questions. So today also we have taken few numerical, 2-3 numerical, and we will solve and we'll end this casting chapter in today's lecture. Next lecture onwards, we will start the welding and the remaining manufacturing processes course. So today, as I said, we'll discuss few numericals. One will be on solidification time and one will be in based on core. So whenever core is there in the casting, so we know there will be hydrostatic forces on that one. That is the forces on that. So we know that from if something we are immersing in a liquid, so we know always there will be force of buoyancy that will act in opposite direction to the weight of the car. So based on that also we'll take one more numerical and we'll try to solve that and we'll end this chapter. Then next lecture we'll start which will be based on the welding. So first numerical that I have taken, this is also gate question. I think it was in 2015. I'm not sure, but it was in 2015 in gate exam. This is based on the solidification time. Solidification time means when you are pouring the molten metal in casting, so how much time it will take for the solidification. Based on that, we have solved a lot of numericals. Today we have taken one more numerical based on that. So we'll see how to solve this one and also we'll see what the concept behind. So we all know when a casting it solidify, that is when we are pouring the molten metal in the sprue, from a sprue it will go to the pouring basin and then it will reach to the sprue, then it will reach to the base, and in this way it will through all the sections it will pass, that is through all sections of the gating system it will pass, and finally it will reach in the mold cavity where it will, if you leave for some time, it will solidify over there, and after solidify we'll take it out. So how much time it will take from pouring to reaching over there in the mold cavity and then solidifying over there, this is the time of solidification time. So there is experimental result how to find out. So we already know this solidification time is given as a constant volume upon surface area, a square of this one. This constant we have already discussed. This depends on the material that we are going to cast. Whatever the material is, accordingly the value of this K or the value of this constant will change. For example, suppose we are casting aluminum, the value of K will be different. We are casting some other metal, suppose cast iron we are casting, so value of K will be changed. Okay, so it totally depends what material we are going to cast. Accordingly, the value of this constant will change. Okay, so in this problem, two castings are there. One is having cube shape and another one is having a spherical shape. So what it reads this numerical, a cube and a sphere made of cast iron. So what is the material? Both are made of cast iron. So if both are made of cast iron, that means this constant K will be same for both. Each of volume 1000 centimeter cube. So volume of both the cast shape is given. It is 1000 centimeter cube. We are cast under identical conditions. All the conditions are same. Okay. The time taken for solidifying the cube was 4 seconds. So cubical casting time of solidification is given. It is 4 seconds. So what we have to calculate? We have to calculate what will be the time for solidification for the sphere. So what we will do? We know this formula, solidification time. How to calculate? T is equal to constant K into volume upon surface area whole square. So what we'll do? Simply we'll apply this formula for both the shape, that is cube and the sphere, and we'll try to find out how much time a spherical casting will take. Okay, so what we are writing? We can easily write first in the problem it has been given that volume of both are same. Okay, no? So what we are doing, we'll take the formula, this T is equal to, we know, so if we are taking time of cube, I am writing C, and time solidification time for a sphere we are writing TS, that will be equal to constant volume of cube upon surface area of cube whole square divided by constant k volume of a sphere divided by surface area of a sphere and whole square of this one. Okay, so this k and k will be cancelled out because clearly it has given both are made up of cast iron. So this constant will be cancelled out, and this volume also is same. This Vc and this volume of the sphere, this is also same, and this will go in the numerator. So finally this expression will comes out surface area of the spherical casting upon surface area of the cube and whole square of this one. So what is this ratio is Tc upon Ts. This is equal to surface area of this spherical shape upon surface area of this cubical casting. Okay, now this Tc is given in the problem. So what will be the surface area of the spherical shape? We know it is nothing but 4 pi r square, where r is the radius of the sphere, divided by surface area of a cube. We know cube is nothing but the combination of, or the it has been assembled by 6 square. So if one side is small a, so we know what will be the area, 6a square. So it will be a square of this one. This will be the ratio of surface area of a sphere upon surface area of cube. Okay, now what we have to do, we have to find out this ratio. Tc is given in the problem. So if we'll write this one, this implies, so we can write 4 upon this 4 second it is given upon Ts that we have to calculate is equal to, this is 4, so it will be 2 and this will be 3. So it will be 2 pi r square upon 3a square, this whole square. Now this 2 pi is constant, 3 is constant. What we have to do in this one, to get the value of Ts, we will have to calculate the value of radius of the sphere, and we have to calculate the value of what will be the side length of the cube. For that, here the relation is given. What the relation is given, I am writing here, it is okay, I think it will be visible. Yes, I am writing here the volume is 1000. So 1000 we can write is equal to 4 pi r square. Okay, this implies if we will calculate r from here, the value will comes out 6. The value I have written, the value of the radius will comes out, it will be 6.20 centimeter. Similarly, 1000 for the cube is equal to, we all know it will be a cube, side cube. So this implies a means side length of the cube will be simply 10 centimeter. So now we have the value. We have the value of the radius of the sphere, and we have the value of the side length of the cube. So directly we can put here, if we will put here, so this will be equal to 2 into pi and this r square. R square means this we can write 6.20 a square of this one divided by this 3, and this is a square of 10 and this whole square. Okay, so this value we can calculate. We will calculate on the second slide. So what this value is actually 4 upon solidification time for the sphere, and this is equal to, as this is behind, so I am writing it again. So it will be 2 pi and the radius is 6.20. So 6.20 square of this one divided by 3a square means 10a square and this whole square. Okay, so from here we have to find out the value of, so what we will do, we will calculate all these things, and once we will calculate, we will get the value of this solidification time for the sphere. After calculation, we will get this value 6.15 seconds. That will be the answer. I hope calculation everybody can do. This is not a tough calculation, and in GATE you already know calculator is also allowed. So easily, once you will put all the value, not all, we have already put all the value, so just we have to do the calculation, and once we will do the calculation, finally we will get the value of solidification time of the sphere, and it will comes out 6.15 seconds. Okay, so this will be the solidification time. So this is quite easy, it's not a tough numerical. The only thing, if you know how to calculate the solidification time, the thing is how to use the formula, and also the importance of that constant K. If same material we are casting, so that value of K will remain constant. That is very, very important. Next numerical, as I said, we'll take and we'll find out, that is totally based on, as we know, why do we use core in casting? Core generally is used whenever we have to produce a hollow section, just like this one. Suppose I have to produce this hollow cylinder. If I have to produce a hollow cylinder, so through casting, so we know there are two methods through which we can produce this hollow section. One is either we can go for the centrifugal casting, or if we are not using centrifugal casting, so what we will do, generally we use core, generally made up of sand, and that core, whatever the dimension of internal diameter is there that we want in our casting, exactly of same diameter, same dimension, will produce a core, and that core will put inside, okay, to produce the hollow section. So same thing is there in this numerical, but what we have to calculate, actually we have to calculate what will be the force of buoyancy, that we have to calculate. So I am reading the numerical. What is the question? An aluminium. So this aluminium is given whose density is 26 kg, sorry, 2600 kg per meter cube. That is given density. Okay. Casting is to be produced. So we have to produce aluminium casting, and the density of that aluminium is given. It is 26 kg per meter cube. A cylindrical hole of 100 mm diameter. Sorry, this is mm. 100 mm diameter and 100 mm length is made in the casting using sand, and this core density, that is this core is made up of sand, and its density is given, it is 1600 kg per meter cube. So this is given. What we have to calculate? We have to calculate the net buoyancy force on the core. So we all know what is the meaning of buoyancy force. Buoyancy force comes into picture whenever a solid body is either fully or partially dipped inside a liquid. We know always liquid will exert a force in upward direction opposite to the weight of the body, which force is known as buoyancy force. That is force of buoyancy. So what we have to calculate here, what is the net buoyancy force on this core, that we have to calculate. So we know density of this casting is given, and density of this core is given. It's very easy to calculate. We know what is weight. Weight is nothing but mass times acceleration due to gravity. So what will be the net force? Yeah, net buoyancy force. So directly we can write net buoyancy, B-O-U-Y-A-N-C-Y, sorry, buoyancy, B-O-U-Y-A-N-C-Y, net buoyancy force on core. We can write density of the casting minus the density of the core into, this is the density, now multiply by volume, so it will give mass. So what will be the volume? It is cylindrical, so pi by 4, diameter square, core diameter, length of the core into acceleration due to gravity. So weight, we all know weight is nothing but weight is equal to mass times acceleration due to gravity, and mass is nothing but density into volume into g. That's what we have written here. So this density difference, density of the casting minus density of the core into this volume into acceleration due to gravity. Okay, this one I just wrote for the understanding. Okay, so now all the value are given in the problem. What we'll do, directly we'll put the value and we'll do the calculation and we'll get the value. It will be in Newton. It will convert all the unit in SI unit. So this rho C is given. We no need to change anything because it is given in SI unit. So it will be 2600 minus this will be 1600. That is given into pi upon 4, and this diameter will be 0.1 because it is 100 mm. So 100 upon 1000, it will be in meter. So this one is square into length. This one is also 100 mm. So 100 upon 1000, it will be 0.1 into the value of acceleration due to gravity is 9.1 meter per second square. Once we'll put all this value and once we'll calculate, this will comes out 7.75 Newton. So it's a very easy numerical. This is also great problem. get problems. So very easily we can calculate. The only thing is we should know what is the meaning of buoyancy and how buoyancy force is calculated. So just this formula we don't need to remember this one. If we know how to calculate the buoyancy force, so easily we can apply and easily we can calculate the value of force of buoyancy. So we'll stop our lecture here. So casting this unit is over. Next we'll take welding, and there also we'll discuss first theory, and whatever the numericals are, especially the gate based numerical, we'll try to solve, and through numerical also we'll try to understand whatever the underlying concepts are. So thank you. We'll stop here. Thank you.